For those of you joining us, welcome to the 2025 Access, Innovation, and Disability Symposium. We're so excited to have you here with us for our last session of the day, but please still continue to join us for tomorrow as well. Funding for this symposium was made possible through CU Boulder's Impact Grant, the Office for Access and Community Engagement in the College of Arts and Sciences, CU Libraries, and Be Well. My name is Sonja. I use they, them pronouns, and I am a member of the symposium's planning committee. For those of you that require a visual description, I have a long curly brown hair, glasses, a kind of thick necklace, and black shirt, and I have a background with a QR code and the disability flag transposed over some views of the local mountains. Before I introduce today's presentation, I would like to remind everyone to please mute themselves during the presentation, and that closed captioning is available by clicking that CC button in the square at the bottom of your screen labeled captions. You can also find it, if it is not showing up at the bottom, under that more button at the bottom of your screen with a circle with 3 dots in it. It will still be labeled with that CC in the square and with the word captions. Please do feel free to use the chat and your reaction emojis during the presentation to interact with one another. We will be using the last 10 to 15 minutes of this hour together for questions, during which time you're free to raise your hand or use the chat as well. And Mauricia has also added, our sessions for tomorrow in the chat if you would like to take a look at those. So thank you for joining us for accessible data representations for screen reader users. And our lovely speaker, Jonathan Zong, who is an assistant professor of information science at the University of Colorado Boulder, where he leads the data and design group. He's also a faculty associate at Harvard's Berkman Klein Center for Internet and Society. In his research, he partners with blind collaborators and study participants to co-design accessible interfaces for non-visual data exploration. He has also developed systems and frameworks for technology refusal and data ethics, supporting communities to resist harmful data collection practices. His work has been recognized by the MIT Morningside Academy for Design Fellowship, the Paul and Daisy Soros Fellowship for New Americans, and the Forbes 30 Under 30 Scientists. And then a reminder also as well that this session will be recorded and will be added to the ACE Offline YouTube channel, and that link is also available for us there in the chat. If you have any questions, feel free to reach out to me about Zoom or any piece like that. And with that, I'm going to go ahead and hand it over to Jonathan.
All right, thank you so much, Sonja. My name is Jonathan. I'm a new faculty member here at CU as of this year, so it's really exciting to be here and to have this chance to connect with the broader CU community of people who are really passionate about creating more inclusive and accessible spaces. So I'm going to talk a bit today about my research, which is on designing accessible data representations for screen reader users. And this is work that I'm doing in collaboration with the Data and Design Group, which is a new research group that I'm leading here at CU. And we're based in the Information Science department, and a lot of what we do is around this idea of doing prototyping and speculative co-design with blind and low vision collaborators in order to kind of try to imagine the future of what assistive technology for BLV folks might look like. And so the focuses of this talk is about kind of sharing our exploratory research and some of our ideas about design for accessible data interfaces. So it's more about, it's not like a how-to of maybe how to comply with existing, accessible data visualization guidelines, but more sharing insights from our exploration into what these interfaces could be like. And I want to highlight, some of the team and collaborators behind this. So in addition to me, I'm, a researcher with a background in data visualization and human-computer interaction. And I did my PhD at MIT on kind of design and accessibility. Um, we also work closely with a collaborator, Daniel Hesh, who's an innovation manager at the Global Disability Innovation Hub. And he's been a kind of long-term collaborator on a lot of these projects, bringing his lived experience as a blind researcher who, works with data a lot, with his background in physics and informatics, but also as, an experienced designer of assistive technology. And so bringing together these different forms of expertise into our work. And a lot of the work that I'm going to talk about today is also kind of in collaboration with my former colleagues at MIT. So thank you to everyone who supported this work. So just to kind of launch into this, right? To provide a bit of background, there's about 7 million people in the United States alone with some form of visual disability, according to a survey conducted by the National Federation of the Blind. Um, but for these people, when we're looking at kind of like the top 1 million pages on the internet, a whopping 96.8% of them kind of fail to meet basic accessibility standards that support screen reader use on the web. Um, and if you're not familiar with what a screen reader is, it's an assistive technology that kind of narrates elements on the computer screen as text to speech. And there's a cursor that you can kind of move across different contents and have it read out. But when you think about things like data visualization, so that's like charts, graphs, maps, things like that, um, they're a very particular kind of visual content, and the average kind of screen reader experience for data visualizations is something that's kind of like this.
Image, 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 image. One face. Image. Logo other. Image.
So that's not ideal. So that example comes from, an example of an election map that was on um, a prominent news site, I think in 2020, and that video was taken by Sarah Fossheim, who's an accessibility advocate. And so, given that, a lot of important content about, not just elections, but things like public health, other kind of civically important things. A lot of this information is communicated through visualization now. Um, the question I'm kind of interested in is, how do we make these charts more accessible to screen reader users? Um, and part of the challenge of this, right? So like the reason why it might be hard to do a good job at this is this idea of designing for modality differences. So visualizations have these visual features that sighted readers are kind of shifting their attention to on the fly, and people can focus on different parts of a chart, move between high-level patterns and detailed data points. And they're doing this kind of implicitly through visual perception. But when you're using a screen reader and you're kind of, using arrow keys to like traverse some sort of predefined reading order, it's very different because then you're not able to kind of like shift between different parts of a chart as easily as if you were just using visual perception. So when we look at kind of what the current best practices are for making, charts and graphs more accessible, there's two main approaches that people often recommend. So one is alternative text or alt text, as it's usually called, and this is kind of giving a description of the information that's conveyed in the chart that's kind of meant to be equivalent. So maybe for that map example I showed in the video, the alt text would be map of 2020 US presidential election results. Joe Biden has 227 electoral votes, Donald Trump has 213 electoral votes, and 98 votes remain. The other recommendation, often used alongside alt text, is the idea that you should be making a data table available alongside the chart so that screen reader users can also be exploring the underlying data. So I have an example on the screen of kind of the table of data that might have been used to generate a map like the one that I showed in the video. And so when we look at these existing best practices, they're definitely better than, image, 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 but they do have their drawbacks. So one is that, for alt text is this single static interface. So essentially what's written in that alt text is all you get, and there's no ability to kind of change it after it's presented. And I think part of the issue with this is that there's a lack of control over information granularity. So, for example, the alt text says that Joe Biden has 227 electoral votes. But if we wanted to know what states those votes came from, if we wanted to like break apart that single number into its kind of constituent parts, it would be really hard to do that with just the alt text as written, even though it'd be easier to do that visually with the map. And so the data table kind of addresses some of these issues with alt text by, maybe having some more granular information, right? You can kind of explore the data row by row. There's, a column in the data that says which state each of the records in the table are from. But this is very tedious and time consuming, right? So the data table for this map might have like hundreds of rows, right? And so if you imagine having to kind of listen to every entry one at a time, it might get very tiresome. And I think beyond that, it's not really equivalent to what the visualization is doing. So, for example, it's kind of difficult to understand high-level patterns when all you're given are the individual data points. And this kind of goes back to, the way that people talk about the value of visualization, right? You're not just kind of converting a table into a different form, but you're leveraging kind of features of visual perception to maybe highlight some of these higher level patterns. And there's like a storytelling aspect to it. And this idea of kind of exploring the data is kind of hard to replicate if you only have a table and maybe some alt text. So I think, because of these limitations of some of these existing best practices, there are some consequences for blind user agency. So when we talk to a lot of blind and low vision screen reader users about, their experiences getting access to data, they said things like, we're at the mercy of alt text writers who maybe make assumptions about what data I'll be interested in. Another person said, it's hard to do your own analysis and be given a text description that you just have to trust. And then finally, someone said, I'm kind of desperate for anything I can use to analyze data. So there was a desire to kind of be more, have more agency, like be more in control of this like process of making sense of data and not kind of just have to rely on an interpretation created by a sighted person. So our research team kind of got together and we were thinking about these issues, and we started a project that was around understanding, design dimensions of richer screen reader experiences for visualization. And I'll talk a bit more about what I mean by design dimensions in a little bit, but I essentially mean kind of like thinking about the different design considerations that would make, a screen reader experience of visualization more useful and things that designers should consider. And this was research work that we presented at the Euroviz conference in 2022, and it received a best paper honorable mention, which is exciting in the sense that it was a good signal that the visualization community was recognizing that accessibility was an important issue to think about. So I'll get more into kind of what this work entailed, but first I'm just going to show an example of one of the design prototypes that we created in the course of this research exploration.
Let's say I'm using a screen reader and I encounter this scatter plot on a page. With Ollie, at first I'll hear an overall description of what the scatter plot is.
A scatter plot with axes flipper length, mm, and body mass, g.
Let's say I want more detail about the scatter plot, so I can press the down arrow key and expand this structure to the next level where I can get information about the different axes and legends of the chart.
X-axis titled flipper length, mm, for a quantitative scale, with values from 172 to 231.
And once I'm on this level, I can press the left and right arrow keys to cycle through the other elements on this level.
Y-axis titled body mass, G, for legend titled species, for an
Let's say that I'm interested in getting more detail about the x-axis, so I can navigate back over to the x-axis with the left arrow key and then press down again to descend into a further level of detail.
Y-axis titled, X-axis titled,
Now down arrow to expand.
1 of 7, flipper length, mm, is between 172 and 180, 7 values. Press T to open table.
And on this level, I get information about the intervals along each axis.
2 of 7, flipper length, mm, is between 180 and 190, 3 of 7, flip 4 of 7, 5 of 7, 6 of 7, 7 of 7.
So what I just showed was a video of, one of the software prototypes that we created as we were kind of exploring like alternative ways of presenting um, visualizations to a screen reader. And I just want to kind of highlight some of the differences that we were focusing on between, this prototype that we developed and some of the prior approaches that I mentioned earlier. So I think one important difference is that we introduced this idea of a hierarchical structure. So in the video, I was kind of showing, at first when a screen reader user encounters this visualization, they're focused on kind of like the top level of like a multi-level structure where the top level is kind of providing an overview of what the chart is. So it's saying like a scatter plot with axes, flipper length, and body mass. And we had a way, by pressing the down arrow key to kind of descend one level into the structure and kind of increase the level of detail that you were looking at, right? So you could go down a level and instead of having the overview, you would get information about the different axes and legends, and then down another level and you could get the intervals along the axis, and then finally all the way down to individual data points. And this is in contrast to maybe a conventional screen reader interface that might have a very linear structure where you can kind of, you can go forward and back like along a list of things, but it's harder to kind of control different levels. And secondly, I think an important thing I want to highlight about this prototype is that there was kind of free control over navigation, right? So as I was describing that structure where you could, go up and down levels of detail and then like navigate along different things within a structure, we were really focusing on the idea of, having someone be able to do self-guided exploration through the data. And I'll talk a little more in a second about, different navigational ideas that we had. And finally, we had these descriptions that were at varied levels of information granularity. So, rather than kind of going through each individual data point or maybe only giving a high-level summary, you could kind of move between these levels of detail, gradually break information down so that you can kind of only focus on the things that you're interested in and kind of not have to flip through the entire data set to kind of get a gist of the whole thing. So when I mentioned earlier that this project was kind of around identifying design dimensions for screen reader interfaces, I think the question we were really trying to answer is this question of how should designers think about screen reader interfaces, right? What are the things that they should consider when they're like creating these different ways of presenting data through interactive descriptions? And so the prototype that I showed earlier in the video is maybe one example of, a system that we designed by working through some of these considerations, but we were really trying to identify some of the things that could help other people incorporate these ideas into their designs as well. And the design dimensions that we kind of identified through our co-design process were structure, navigation, and description. And so I'll kind of walk through these one at a time, starting with structure. So when I talk about structure, I'm referring to the way that you might organize data and visual elements into a format that can be traversed by a screen reader, right? So I mentioned earlier this idea of a hierarchical structure where we have, a summary at the top level, and then you can go down a level and get information on the axes, and then go down a level to, like intervals along the y-axis, like, 20 to 30, 30 to 40, and then finally down to the individual data points. And this may be in contrast to other ways of doing structure, like linear structures, where, I've seen existing visualizations on the web where they basically like alt tag every single point on the scatter plot. And then maybe you have like the summary, the x-axis, the y-axis, but then it's like data point, data point, data point, and then there's like 500 of these, right? And you can only go like one at a time and like not really skip over anything. So we thought that it was really important to pay attention to structure, because visualizations are often kind of read in this like multi-level way where you want both overview and detail. Secondly, we have navigation. So by navigation, we mean, now that we have a structure for a screen reader to traverse, how is the user kind of moving around the structure, right? And in the video, we were kind of demonstrating what we were calling structural navigation, which is kind of exactly, moving up and down different levels, moving left and right along the same level, kind of traversing that structure that we've created. But we also had other ideas about, how navigation could work. So for example, we were thinking also about spatial navigation where, you're moving within the space of the visualization. So like maybe up means like towards the top of the chart rather than higher up in level of detail. And you're kind of moving along these X and Y axes spatially. And then finally, we were also thinking about targeted navigation. So we were thinking about, maybe a reader of a chart kind of has an area in mind, like within the data that they're already interested in, and they don't necessarily want to kind of figure out how, like the sequence of arrow keys they need to like move themselves there. So targeted navigation is kind of about jumping directly to a known location, and we were exploring kind of different menu structures that could do that more directly. And then once you arrive where you're interested in, you can kind of maybe like locally explore using the arrow keys once more. And finally, for the last design dimension, we were thinking about description. And we kind of broke description down into three, I guess, kind of like considerations within description. So the first is content. And with content, we were really thinking about like what is the kind of meaning of what's being described uh, within the description. So there's different aspects of a chart that you could be describing, right? There's maybe lower level kind of elemental things like what type of chart is it? What are the axis ranges? What are the colors, etc. And then maybe slightly higher level things like descriptive statistics, outliers, things like that. And then finally, if you go even higher level, beyond kind of these like elemental or maybe like even like statistical summary ideas, you get to some of the like perceptual features, right? So you could be describing things like the trends, the patterns, etc. in the chart. And then at the highest level, maybe there's like contextual and domain specific information that you might need to interpret the chart, right? So maybe a description is describing like domain specific insights or maybe like current events or social and political context. And so, focusing on or deciding which of these levels to kind of focus on when you're writing a description is actually, pretty important because it'll depend on what the reader wants to get out of the chart. And secondly, beyond content, we also thought about composition, or maybe like ordering is a simpler way to say this, where we were thinking about, because a screen reader user is listening to this description kind of from start to finish, but there might be something that they're kind of specifically looking for or that's more useful to the current situation. It's really important what information you kind of put towards the front of the description that's being read out versus towards the end so that if someone hears what they're looking for, they can quickly move on to the next thing and save a lot of time in the long run. So for example, if someone is looking for like a specific category in the data, then having the category closer to the front of the description is better. But maybe if someone's looking for the third data point, then having, the numbered index towards the front is better. So again, these are kind of ways of thinking about like contextual factors in what might make a description more useful than another. And then finally, we were thinking about verbosity. And so screen readers kind of typically have like verbosity built in as a setting. But usually this is about like, skipping punctuation marks or, or what things to like what type of metadata to show or not show. And with verbosity here in this context, we were really thinking about, the actual like the wordiness of the descriptions. So for example, someone who's new to an interface like this um, might prefer a wordier description that's like interval with 6 values in the range 20 to 30, because that helps you kind of interpret what those numbers actually refer to. But someone who's used an interface like this a lot of times and has heard interval with, so many times, they might prefer a description that's just like 6 values, 20 to 30. And that's quick and efficient. And because they're experienced, they might already know what that means. And so, I won't go into it too much in this talk, but we actually did some more research as well, kind of exploring ways for people to customize these three aspects of description. So adjusting content, composition, and verbosity on the fly as they're exploring charts. So I'll just show here on the screen, this is kind of an example gallery of, different approaches that we tried out during our prototyping process with different, chart types, including like dot plots, stacked bar charts, line charts, things like that, just to kind of show that, the approach we were exploring in our prototyping kind of can apply to a lot of different types of charts. And so I think this work has, to my delight, had, I think, quite a bit of impacts, at least within the visualization community, in terms of, changing how researchers are thinking about what it means to make an accessible data experience. So for example, I'm showing on the screen, there's new research coming out from researchers at places like CMU, Microsoft, MathWorks, and Tableau, and they're all kind of building on this work of design dimensions and incorporating that thinking into their own systems that they're building. And I've also been really pleased that, a lot of this work has had an impact in terms of contributing to public conversations about access to data, especially in the context, maybe of like um, uh, increasing the number of blind and low vision people who are able to access careers in science and in STEM. And I think that's, something that's really important to me as an educator, as well as making sure those pathways exist. And I think having some more, options for accessible tools can help with that. And finally, we've released a lot of the software that we've developed during this project as an open source library called Olli. That's OLLI. And you can find that some information about that software on the Data and Design Group's website, which is data-and-design.org. And we have project pages for Olli. So that's all really exciting. And we've made some progress since we set out to address some of these questions. But I think when we were reflecting towards the end of this project, we could see that there were still a lot of remaining challenges to address. And I think especially as we were talking to our blind and low vision collaborators and participants and colleagues about why it was important to them that they had access to data visualizations and things like that. People were saying, I want to participate meaningfully in a discussion at work and not seem clueless. Or as the only blind person on a team, consistently being the only person who can't comment on a topic, can affect promotions and work opportunities. And someone also said, am I going to keep depending on collaborators to do all the analysis, or am I going to, keep trying to find ways to do it myself? And I think this really highlighted that question of agency that I brought up earlier, where, people were saying that they felt like they just had to trust the description provided by a sighted person. We kind of realized that there was like a fundamental question around like participation and power. And this idea that, maybe we were making visualizations created by sighted people accessible, but is access to other people's charts really enough? Like, was there a way, that we could empower screen reader users to not just get access to other people's charts, but to create their own interactive data representations? So that was kind of the guiding question that, we sought out to address in our kind of follow-up work to this first project that I presented. Um, and so, thinking about the idea of like enabling screen reader users to like author their own interactive data representations, right? Um, why might this be hard? So I think part of the challenge is that, we looked at some existing authoring tools, and uh, there was a kind of prevalent issue that a lot of authoring tools were kind of centering visual specification in their workflows. And what I mean by that is, some existing tools that we looked at either required a visualization to already exist in order to convert it into a non-visual format, or if you could, create a non-visual representation from scratch, you kind of had to create it in visual terms. So you had to like define an X and a Y axis in order to then, convert it into back into a non-visual thing. Um, and I think, this idea of visual centrism in authoring tools has a few consequences. Um, so the first is that, blind and low vision users have to specify their intended non-visual designs in visual terms, kind of like translating to another modality and then translating it back into the one they want. And I do work in the field of human-computer interaction, and we have kind of like a technical term for this called the gulf of execution, which is when we think about, the distance or like the gulf between an idea that someone has in their head of like a thing that they're trying to do, and then the distance between that and being able to translate that into like a sequence of actions they can execute like on the computer or in an interface. So I'm arguing that kind of this visual centrism widens that gulf of execution by kind of requiring more thinking to like figure out how to do what you're trying to do, or create what you're trying to create. And then there's this second idea that not all non-visual designs can be expressed in terms of an analogous visualization. So if you're assuming that, you're going to make a visualization and then convert it to something else, um, there's a lot of like, sonifications or other types of representations that you might be missing out on because they actually don't have an equivalent visualization. So in human-computer interaction terms, we would call this the idea that visual-centric systems have limited expressivity. And just for example, I have some examples of like documentation from existing tools, which I think are like amazing tools. And this is like a kind of a problem that like everyone is facing, right? So I'm not kind of trying to single out certain tools. But for example, like, there's tools that can only kind of accept, certain types of visualizations that either, have like a bar or a line format where there's a really clear, like maybe, time series or something that makes it really obvious, like how you would kind of sequence it for a sonification. And there's also examples of tools where, they have in the documentation, like there's plot types that can be described but cannot be explored using a sonification because, again, maybe they have like a kind of um, visual structure that maybe doesn't obviously map onto a sonification. So there's kind of like a mismatch in these different modalities that might be posing an issue. So we ended up, conducting this project, me and my collaborators, around how can we design, an accessible authoring tool that tries to prioritize decentering the visual modality. And that was kind of like the guiding principle between the way that we kind of approached thinking about how this would work. And we ended up with this software system that we've released as open source, and it's called Umwelt, UMWELT. And I'm trying to decide if I should go into detail about why it's called that. Like Umwelt is kind of this like term for someone's like like subjective like perceptual experience. So it's this idea that's been taken up in disability communities around the fact that we all have different sensory capabilities, and there's no kind of like normative way of experiencing the world. And so we were kind of getting at that idea with this idea of an editor for creating multimodal data representations that kind of leverage a lot of different sensory modalities, including visualization, but also those interactive descriptions that I mentioned earlier, and also sonification. Um, and just to kind of explain the screenshot that I have on the screen, there's like the left side of the tool is like an editor, and you can kind of upload a data set and choose what fields from the data set you're interested in, and then you can kind of assign those fields to different, features of the multimodal output. So you can assign it to like an X or Y axis or a color channel, or you can also, pick non-visual features like the pitch of the sonification, and you can do that all in the editor. And then in the viewer, you have the three types of output that I mentioned. And so I'll just run through an example of like how someone might use Umwelt to create a multimodal data representation. And I'll walk through an example that focuses on this idea of decoupled authoring of modalities. So addressing that problem earlier that I mentioned of like, for a lot of tools, you have to create a visualization first and then translate it into the other things. I'll demonstrate a way with Umwelt that you don't have to rely on the visualization to create your non-visual output. So first, in the editor on the left, you would upload a data set. We're using this kind of example penguin data set that was also in my other video. And at first, it just kind of shows you all the different fields in the data set, and all the fields are kind of checked by default. And already, just from that, you have an interactive textual description that's in the viewer. And because there's no visualization right now, it's just the data set, the description kind of reflects that. So instead of saying it's like a scatter plot or whatever, it just says it's a data set with 7 fields, and then it kind of breaks the data down by fields. And so now if a user kind of decides like, oh, I'm really interested in the beak length field, they maybe uncheck the other fields. And then in the viewer, it kind of automatically updates to now focus in on that beak length field that's selected. And if you go down a level, it'll break down that beak length into different intervals. So, 35 to 40, 40 to 45, etc. So let's say now that you want to add a sonification, you can go to the editor and you can go under the menu for beak length, and then you can add an encoding, which is just assigning that field to some sort of sensory output. And in this case, I've selected a volume encoding. And once you've selected that, in the viewer next to the textual output, there's now a set of audio controls that controls the sonification, and it's showing binned beak length with the volume mapped to how much data is within each interval of beak length. So if I play that back, it'll sound like this.
30, 35, 40, 45, 50, 55.
So it was playing a tone for each interval of data, and a louder tone meant that there were more penguins with a beak length that was kind of in that interval. So let's say now, like, so far we've made a textual description and a sonification. Maybe we also want a visualization, right? Just to have one. And so I can go back to the editor. In addition to that volume encoding for beak length, I can also add an X encoding, and then maybe I can check the box for the species field and bring in the species field and map that to color. And then I end up with this dot plot of different penguins colored by species, and it's mapped to different beak lengths along this line. And now that we have a visualization, the textual description can update to reflect that. Now it says it's a point chart and it has an axis and a legend. But I guess the point I want to highlight is, we didn't have to have that visualization at all if we didn't want to. And we were still able to create, the non-visual modalities with text and sonification. Now I'll quickly walk through a second example using Umwelt. And this example is going to focus on that earlier idea of expressivity from having these different modalities. So here I have, an example scatter plot of body mass versus flipper length for penguins, and an example sonification as well. And the point I want to make is that the sonification is actually different from the visualization. But let me play it back first as an example.
2,700, 3,000, 4,000, 5,000, 6,000, 170, 180, 190, 200, 210, 220, 230.
So what we were listening to is basically it was kind of scanning across each of the axes. So first it was body mass, then it was flipper length. And a higher tone just meant that it had a higher average value for those penguins along those intervals. But I want to make the point that for this sonification, I mean, I think it would be useful for, if you were trying to understand a distribution, kind of understanding the trend along an axis. If you were to convert those back into an equivalent visualization, it actually wouldn't really look like the scatter plot that's in the viewer. It would look more like these two separate bar charts because there's binning applied to each of the axes. And you can see visually with these bar charts the kind of distribution, right? And how there's an upward trend, and it's kind of the same trend that you hear in the audio. But with the sonification, you're focusing on that trend, and you're not really listening to what are the individual data points for each individual penguin, right? And you can make a sonification like that, but that'd be a different sonification. But what I'm saying is, there's kind of a difference in focus between the visualization and the sonification. And my argument here is that, when you have these multimodal systems that kind of treat different modalities equally, you can actually use the modalities in complementary ways. So, for example, the sonification design has a kind of clear, task-driven use of conveying the distribution along each axis. But if you want to kind of understand individual data points, like you would be able to with the scatter plot, you could go to the textual structure and kind of maybe, navigate into the x-axis, break apart the values into their individual data values, and it would read those values to you. And that might be better because hearing, the screen reader read, oh, this is, 219 millimeter flipper length would actually be easier for understanding that number compared to, a tone that's pitched a certain way. But, maybe none of us have perfect pitch, right? Or maybe some of us do. So I think, the point here is that having these multiple modalities actually kind of opens up the space of, what you're able to create with these tools if you're not just kind of focused on replicating the visualization. So here I'm just showing again another example gallery of different types of data representations that we've created with Umvelts that cover a lot of different types of charts, line charts, scatter plots, bubble plots, and kind of their corresponding interactive text descriptions and the sonifications that might go with them. So coming up onto the end of the talk, I just want to say, thank you again to the organizers of this event for, giving me this opportunity to connect with the broader CU community. And, I want to thank all my collaborators on all this research. And, we're just getting started here at CU. So the Data and Design Group, as I said, is a new research group as of this year. And this is an area, we care deeply about working on and kind of expanding this work in the future. So if you want to connect, you're able to find information about this research group at data-and-design.org. And I'm looking forward to having a conversation and answering questions. Thank you.